Thanks, Rohit. Uh, Thanks for
Hi,
having
Kamesh.
me. Yeah, thanks, Rohit. I think thanks for having me in, and good morning to everyone, wherever you are. I think mostly from India, Bangalore, Europe, anywhere you are from. It's
Yeah,
really a pleasure to meet you in another CodeOps conference happens, and thanks to CodeOps and KonfHub for having me in. It's really a pleasure to speaking to you all, the community, at this particular time where I rarely go and speak in public conferences. So it's really kind of a refresher for me, and I'm going to share you some exciting stuff today around OpenShift, Azure, Kubernetes, and Kafka. That's going to be our core talk today. So I have put down. So let me quickly go and share my screen before I go further. So that's going to be share. Right, I'm just going to share my screen, and
I'll just put it on the screen, Kamesh.
yes,
Sure. Okay, then all the best, Kamesh, for the session. I
thank you,
hope
thank
like
you,
people
Rohit.
will be enjoying it and it will be very much engaging and people will be posting their asking their questions on the comment box. So if time permits, please answer the questions.
Sure, definitely.
Okay, great.
I'll wait for my slides to come up. I'm there. I have my slides up. And this is going to be my talk today. So 4K cloud data streaming. So with Kubernetes, Kafka, Knative, and Camel. That's the reason why I call this as 4K. And then you can find the slides right there on the link below, dn.dev slash 4K dash Kubernetes. That's the slides where I'm going to share today. So I'll be using the slides just to run through the context, but the complete detailed slides are available for you. So you can just download from that link and then start using that. And before I go further, let me quickly introduce myself. And then if you have any questions, probably you can just ask me on this. I'm sorry. So just to say you like I'm a new altogether a new machine because of a problem with my Mac. So I might be having some typos while typing. Excuse me about that. And this is about myself. I work as a director for developer experience in Red Hat, and I'm one of the Google developer experts in India for cloud. And then I recently launched my book. That's a book there, Knative Cookbook. So probably you can just download the free ebook from the link that is there. Just need to register yourself at developers.redhat.com to download the book. I'm also an active open source contributor for quite some time for various projects, and that's my few projects which I'm contributing right now. If you have any questions on this particular session or around Kubernetes, Knative, or anything, please feel to reach out to me to my Twitter handle. I put on my Twitter handle. I have my email ID. I have my GitHub handle as well. Just message me there. I'll be happy to answer your questions as well. Right. So with that, so this is a ebook download link for you. Especially if you download the slides, you'll get the ebook handle. And I also asked Rohit to post these links on the chat so that like you can download the books from via the links as well. Right. So before we go further, just to set the context up, right? So what's the cloud data streaming is all about, right? So we talk about all of streaming, right? We talk about Kafka, we talk about message brokers, we talk about all of the stuff. But before we go further on all these individual components, I want to set up a context saying like what exactly is the need of cloud data? What are the basic needs if you want to do a cloud data streaming, right? So obviously, the first thing is going to be your applications. The applications are getting distributed, preferably microservices. That's a way of things which we are doing right today. So microservices is kind of a probably can call them as one of the way of doing cloud data streaming, right? So that we can scale, distribute the applications across your cloud, right? So that's one thing which you can preferably go with microservices. Another important thing which becomes crucial for a cloud data streaming is that I need a platform, right? I need a platform which is scalable. Most importantly, is a very important aspects. There are other multiple aspects as well, but very important one is that it needs to be scalable. It needs to be resilient, and also like it needs to be resource conscious. So these three things become very important nowadays because the platform is available. So we have platform in very many cloud providers, many individual platform, private data centers. We have an hybrid cloud architecture as well, but the platform has to support these basic things. And apart from that, we also see that so everything around the application, right, around the data or anything, right, is everything is around data, right? And data is never in isolation. You never use one application which is going to use only one data, nothing like that, right? So you just go to talk to multiple different services, get the data from them, do some kind of an enriching on the data, and use the data for your needs, right? Some kind of thing, right? So for typically for the business needs. So which means that I also need to have some kind of integration available for me. And that's a context you're setting to it before we start, and that's where all these four components which you talked earlier, your Kubernetes, your Knative, and Kafka, and Camel K. So I'll talk about that more in detail. All these things comes into picture, right? So if you have any questions in between, as Rohit said, you can just pop your questions up. Rohit, please feel to stop me anywhere, like was there any important questions. We can take questions and proceed further, or I can also handle the questions at the end of the session as well, or as I said earlier, drop me an email with the questions. I'll be happy to answer your questions as well, right? Great. So the first thing we're going to talk about is why we need Kubernetes, right? So as I said, like one of the platforms that we're going to use, one of the component in the platform that we're going to use for cloud data streaming is going to be Kubernetes. But why we need Kubernetes is just for a simple reason. So this is the old school way of doing things, right? For example, on the left side of thing, and the new school way of doing things is using Kubernetes or OpenShift. End of the day, so it's OpenShift is nothing but your enterprise Kubernetes that you're going to deploy your applications on. So earlier days, if you remember, I'm a Java programmer for last 20 years for now. So as a Java programmer, I know that the way to deploy my application is that I make the application as a var or a EAR and deploy that on application server, and it starts running on the application server, right? So, but what happens is that you'll have a typical challenge like this, right? A typical challenge as a Java developer is that whenever I do application development, I have all these problems, right? You package your jar and say, okay, everything is working fine. And then what you do right now is you take an application and deploy an application inside and give it to your ops guys. And the ops guys say, okay, I'm going to deploy my application. But the problem now, what happens is that when he goes and deploy, you'll be probably using a different JVM version or a different application server version or a different operating system or any other kind of configurations, right? End of the day, what happens is that your code is going to break, right? The code is not going to get deployed properly and you're going to go back into that particular loop, right? That's where we went back to using this kind of architecture where we're going to use something like an application orchestrator, which is going to be Kubernetes or OpenShift, which is going to take care to deploy the application as a container, right? End of the day. So everybody's aware, I assume that everybody's aware of container. So we're going to use container-based technologies where I package every other stuff inside a container, and then I'm going to give them the container to be deployed, right? Which means that there is no big issue with these challenges that you're going to face. And also, like when a platform like Kubernetes or OpenShift, we might also need to have I'll have these challenges sorted out, right? Typical DevOps challenges when you're getting into the container world is all these things which are listed on the screen. So, like you're scaling, you're avoiding port conflicts, you need to maintain the actual and desired replicas, and then how to keep them running. And there's a lot of other things comes into picture. So this itself is going to be a talk of its own. But at the end of the day, if you imagine that these are the challenges which you might have faced when you start to develop with containers, so that's what OpenShift and Kubernetes is going to solve things for you, right? I don't need to worry about all these things, the constraint which I've listed on the screen. When I take my application and the moment I containerize my application is going to run on Kubernetes or OpenShift with much of an ease. All right. So that's what you're going to do here. So if you go here, like these are the couple of links which I pasted here, you can go there. And one of the things what I want to say to you is, like, before I even go into the terms, is that how do I get started with these Kubernetes platforms, right? So right now on today's session, so I have my entire things is deployed on Azure. So just going to be on my Azure portal. Let me go to the all resources and show you these Azure links here. So these are the resources which is right there, so which is going to be deployed for me. If you see on my Azure thing, so which is going to be there, and then you can also get OpenShift running on Azure using Azure Red Hat OpenShift, so which is already available for you. You can just get started with your Azure platform. But and you can also go to try.openshift.com, or there is a ebook also for you to download, where you can download this ebook which walks you through the complete steps that is required for you to run Red Hat OpenShift on Azure, right? It's going to give you the detailed steps that is required there. It's a free ebook download. As other ebooks, you can also go to this site, click on this link to get download the ebook, which talks you how to get your OpenShift running on Azure. All right. And also, like if you want to provision, you're an Azure expert, and if you want to do it by your own, you can also do it by your own. So if you go to this try.openshift.com, this is a particular site which I've there put down there. I'm also putting that down on the chat. So that's going to be try.openshift.com. If you go there, you can take this thing, which also has probably, if you already have a cloud deployed, you can deploy your application on any cloud you want, right? So for example, in this case, let's take Azure for this case. So you can take Azure and then put on your Azure credentials and other stuff that's required, and that's going to deploy your entire platform on Azure for you. All right. So, and there's also detailed tutorial also available. I've given all these links to Rohit. Probably will also publish those things, so which gets you started with Azure ARO, which is Azure Red Hat OpenShift, Azure on Red Hat OpenShift, like kind of stuff. So where you can get started with Azure on OpenShift much easily from the CLI as well. All right. And then these are the very important links that I wanted to share with you, where the platform we are running right now from. So once you have all this platform running, right, you might be entering with these kind of little terms, which probably this might something which you're already aware of. But I just thought it could be a nice refresher to see what's a pod, what's a replica set, what's a deployment test, right? Because these are the basic things that you play around when you deploy your application as right? So when you want to deploy an application, I need a pod, and the pods get deployed by deployment, and I use a replica set to scale up or scale down my application. And when I want to access the application from the outside world, I expose a service, and the service is going to get my application to the outside world. And as I said earlier, no application is without data. So which means that I need to have a persistent volume or a volume mounted so that I can attach that to the pod to store the data, so that whenever my pod crashes or my node crashes, my data is safe. I can restore my data and do it otherwise. Okay. And also, like, one of the important things that Kubernetes plays around, I think, since you're, I assume that everybody is aware of Kubernetes, is around the labels, which means that I can have a key pair values associated with each of these nodes or services or deployments, so that I can identify which one, and I can even trace them out or monitor or do whatever other kind of things you want to do as well. And then Kubernetes heavily relies on labels for very many things, including your load balancing that it provides out of the box between your services that's going to be deployed. All right. So with that, so what you're also going to show is, like, so before we go further, so we'll just quickly take how to deploy this. I told you that you can install OpenShift from three different ways. Right now, you can do it manually using the OpenShift installers. You can go to Azure to deploy and all of the stuff. And this, I just want to take a quick overview and then show you how this actually looks. So this is my OpenShift console for you. And if you deploy in any cloud for that matter, this is the one which is deployed on Azure. If you see my URL, for the sake of identification, I have given it as Azure. I'm just deployed this particular application, this particular entire cluster on OpenShift on Azure, which is kind of a 5-node cluster. I have 5 workers and 3 masters, which is in high available configuration. All right. So how do I get deployed with a very simple application? Let's do this. So I'm on my demo project right now. So what I want to go do is, like, I just want to go deploy a very simple application, right? So let me go to my QA registry, qa.io. So if you're not aware of QA.io, just another container registry which is available from Red Hat. So you can use this container registry to kind of download the image and deploy the images as well, right? You can create your free open account as well here. So I'm just zooming a little bit more so that you can see on the screen well. Okay. So you can create your own account here. So I already have my account signed in here. So I'm just going to use my thing here. Let me sign with my GitHub ID. So that's easy for me. So then I have a lot of images inside. You can just take any of those images to deploy the images. So what I'm going to do is, I already have an image. So you can just, these are my repositories which is available there. You can take this just like your GCR.io or Azure repository registry, container registry, or Amazon container registry, or any other Docker Hub. There are a lot of other container registries which is available. This is exclusively from Red Hat. So probably you can just, I'm just using the Red Hat registry for convenience and easier sake. So I'm just going, what you can do is, like, when you go to a topology, let's create a new project. So I called as my demos, and then I can give any name I want. I say my demos again, and then give a description. So the moment I create a project, when I shift to my project, the project gives you multiple ways to deploy your application. So you can deploy it from a source from Git, you can deploy it as a container image, or from a catalog. If you go this, you see a lot of catalog here from where you can deploy your application from. And then we can also go to, let me go back to topology. You can also create a database and connect to a database. If you want to deploy, if you're a Kubernetes expert, you will be having a lot of manifests, Kubernetes manifest YAMLs. You can deploy them from there as well. Or you can also import from a Docker file, which is there deployed on a GitHub repository. All right. So for simplicity's sake, let me go and create one little one with just an external image. So I'm just going to use one little image from here, which I already have. So for the sake of saving my typing errors, I made my commands there. So I'm just going to use this one. So this is your typical image thing. For example, you're going to deploy this image from Quay.io. Okay, I'm just saying use the RS developers, which is the repository which I'm using right now, and eventing hello, and then this is going to be tags and version which is attached to your image, right? And if it's going to be a private registry, you can also create a image pull secret so that like you can pull it from your private. Since it's a public registry, I'm not doing that. Okay, I'm just going to give a name. I'll just call this as eventing hello itself for this sake. It's already put your name like eventing hello have, and it's going to give a name also here. And then I don't want a deployment config. You can choose multiple things. You want to have a Knative service. This all with things we'll see that bit later with the Knative demos. And then I'm going to create a route for the application through which I can access the application from the outside world. And this is all is required for you to get started deploying your very first application onto OpenShift, right? You don't need anything else. I'm just going to click create, and this is going to basically pull the image from an external URL. And then you see this is going from light blue to green, dark blue, which means my application is up and running. And then I have my application available here using this URL. So hopefully I don't have anything on a get URL here. So you see here, I got this basic page, which I kept it ready, saying that your application is available for you via a route, right? I don't even create an application route. You can also stop from application being exposed, but for the demo sake, I expose application so the application is available for you from there as well, right? And then it also given you a qualified URL, and then this URL is also available for you. You can also roll out your own certificates to make it HTTPS, but in this case, I just made it in HTTP. So you can also do all these kind of things. So with just a click of three little buttons, I have my application up and running on Open Kubernetes platform, which is nothing but OpenShift here. OpenShift is nothing but enterprise Kubernetes, which is a hardened Kubernetes for you. Just with click of button, I was able to create a deployment, I was able to create a service, and also I was able to create a route which can be exposed to the outside world. I hope like this is a very easiest and quickest way. The moment you deploy your cluster, you create a cluster using Azure for OpenShift, or try it at OpenShift.com, create your own OpenShift cluster on Azure. There are multiple ways to do that. You can just go find them out from the try.openshift.com or Azure portal to kind of see how you can deploy your own OpenShift cluster. Once you have your OpenShift cluster, it's all easy, like matter of seconds to go find out an image from your registry, use that image inside your registry, and then deploy the application onto your Kubernetes cluster. All right. I hope this gives you a very quick introduction about how you deploy application onto Kubernetes. I'll just take a very quick pause to see if there is any questions before I go further to the next section of the discussion here. Is there any questions? I assume that the silence. I assume that there is no questions. So I'll proceed further with this. So what we did right now is that we are able to kind of take this application and deploy this application, right? But if you just take a pause and imagine, right? I start deploying my microservices inside my cloud, and then I keep running this application. For example, let's take the same application here. I'm not using that for now, right? I just showed you how the application works. But now I go back to do some other work. I'm not using this application at all. But now the problem right now comes is that that particular application is sitting in your cloud and eating your cloud resources, right? Which it could be potentially be used for any other kind of application, which means that I want to have my application to be running only when I need the application to be there. When it's serving the request, come up, serve the request. Once the requests are done, I don't get any request, let's say for a configurable amount of time, then I have to scale down to zero, or what you call as zero, mean saving the resources back to zero, which helps you to do the resource cost optimization. We saw on the first slide where I said what are the basic needs to do cloud data streaming, is that I also wanted to achieve a platform. We got a platform right now, which is Kubernetes and OpenShift. The platform is ready for us to do a deployment, and we deployed an application. That's good. We have the application also deployed. And then now we talk about the resource cost optimization, which means that I want to make sure my application uses a resource very optimally, right? That's exactly what serverless does for you, right? So for example, in this case, within OpenShift, what I also get is like when I was showing you the deployment of the application, I also showed you an option that gives you that I can deploy my application as a serverless application. That's what we are going to do right now, is that serverless computing is basically means that I want to use my resources only when I need them. If I don't need them, then let it be scaled down to zero, which means that I save a lot of resources, including your cost or your cloud cost where you are deployed the application, which means that it's executed, scaled, and built in response to exact demand, right? What I need. Okay, I give a request, give me a response. Once I give a response, wait for some more time to see if there is any more requests are coming. If not, go down to zero, right? That's what we will be doing in next part of the demo. So let's see that. But why we need this? So something which you want to understand before we go further, right? So one thing is that I want agility in cloud, right? I want to deploy application, I want to move application, I want to quickly deploy and see how my application responds to, and all these stuff, right? That's something which you want to do. And also I want to do an event driven. We'll see more about event driven cloud native application when you go to Knative eventing in a second. And then we want to focus on business differentiation, right? When I deploy my application on cloud, right? For example, on an OpenShift platform, so all I want to understand is that I deploy the application quickly and see that application is running for me. Okay, I don't need to worry about anything else, like how do I set up a platform, how do I get the application integrated, and do all of the things, which is not my focus. Because for my business, I want to understand, okay, I introduce a new feature, I want to see how this works. If this works good, then that's perfect. If it's not, let's go back and start doing the other work, right? So if just scrap it out and do something else. And then I want to have a consistent and scalable operations across whatever cloud I deploy, right? I want a platform which is not tied to any particular provider. Basically, I want a platform which can help me to deploy this Knative stuff across multiple things, right? So, for example, like if you see with Microsoft and Red Hat, like we have been doing a project called SCADA, which allows you to do a Knative based, event based Kubernetes scaling, pod scaling as well. I'm not going to talk about that, but I have a resource link on the slides, which you can see that and go read more about that project as well. If you put all these points together, right, when you say agility, event driven, focus on business differentiation, and consistent and scalable operations, that's what it leads to your resource and cost optimization, which means that I'm going to use the cloud in an optimal way, which means that if a resource is not used, I'll take the resource and give it to something else which needs it, or I simply don't use it, right? So say my end of the day, say my operational costs. All right.
Uh,
So
so
that's where I
sorry,
can, yeah, that
sorry to
was
interrupt you, Kamesh, but can you please go a little bit slow because the people are asking.
get a bit slow, even slower. Okay, so
Yeah, I saw a few comments, so a
okay,
bit slower. Yeah.
I'll try to see. I was trying to go even a bit slower, but let me try that. No worries.
Okay. Sure, sure,
I tend to speak fast, so that's my nature of way, speaking faster. So I'm sorry about that.
no problem.
Um, I okay. I'll just go slow. No worries. All right. So let's go back to see the components that is involved when I'm doing a serverless mode of things, right? So for example, I'm going to use Knative in this case. The Knative is already bundled. You can install Knative on OpenShift using operators. So if you're aware of Kubernetes operators, then you can go if you go to the administrator view of OpenShift. OpenShift gives you an operator view. For example, let me go here, and then there is a list of operators which is available there. So this is an operator hub.io. I'm just putting that link also on the chat. So you have just integrated that operator hub.io. So we have integrated that into the OpenShift Dev Console, which means that I can install my application right from multiple different applications onto my Kubernetes platform by searching the operator hub. That is also possible when I kind of do this work. All right. So I already installed, so which means that my Knative platform is available for me. For example, let me go and search this here for you, serverless. I've installed them considering the time we have. Let me, okay. So if you see here, serverless should have something here. Let me go further. Serverless. You see the serverless operator here, which I already installed this year. So you see that I already installed the serverless operator. So which means that you don't see it is already there available on my platform. And then you can just click on that, and then usually it takes you the installation wizard where you install your operators. Give it some time. The operator should be up and running on there. So which means that my current Kubernetes platform is going to support serverless workloads using Knative. Okay, so Knative is a serverless platform that you're using on top of OpenShift. That's going to help. I think you can read more about that when you go here to the operator hub regarding what all the APIs and components being given and what all the things that's available as part of the Red Hat OpenShift operator. All right, let's do that. Let's go quickly deploy the application on a platform as well. I think since we are at the top of the hour, I'll just have 15 more minutes, approximately 14 minutes to get my session done. I'll also show you few other things as well. All right, so let's do the same thing. So let's go to the developer view again, and then I'm going to deploy a new application. You can use the topology here. For that, just click add, and then I'm going to say a container image. I can also do it from command line. Also, I have the option to do from command line, like what I show here. So let's do that as well. Or I can just go here and then take the same image which you deployed earlier. All right, so let's make it a little bit quicker. Okay, let's not click this. Let's go here, and I'm going to go to my command line. I hope my command line is clear, bigger. I'm just checking that out. Okay, it's good. And then just pasting this back. So what I'm basically doing is that I'm just creating a new Knative service, serving.knative.dev, is the API version of this. And then I'm just kind of adding the image here. So the image that needs to be deployed right here is going to be the same image which we deployed earlier as a raw image for the first demo. I'm just going to use the same demo right now, and then I'm going to say create right there. And then right now, if you see this eventing allo, if you see here, this operation is getting created. It's kind of creating a container for you. The container is running for you right now. And then let's go and give this call. I think there's no big call here. You also get a route. You see this here, the route gets automatically created. Let me copy this route, copy a link address, and go to the command line and say curl. Okay, I think this should be something like that. It just echoes back, so nothing big in that thing. It gets back to you the hello world thing right now. So the event gets posted to this, and it gets back to you a hello world in a JSON format. All right. So that's all it does for this particular case on this event. It's a very simple demonstration. But now what I want to show you right now is I just keep this link open right now. And in a moment, you should see this particular resources getting scaled down. Okay. So let's go here and let's click here. And you see this one is getting run right now. And I'm going to leave this for a few seconds without touching anything or giving any request, while I can also take some questions. And you see that it automatically scales down to 0. Okay, that's what Knative is all about, because it automatically scales the resources when there is no use. And also, like when, for example, what I mean by no use, that no request is getting into this particular service, it's exactly the same. It's kind of exposed using a REST endpoint like that, the HTTP endpoint here. So when no request is going to this particular HTTP endpoint, the resource gets scaled down automatically to 0. Okay, you see that right now the application is going back to 0. If you see here, so the scale down to 0, the application has started to scale down because I have not given any request for that right now. So which means that application has to scale to 0. All right. So I hope this a way by which we can start moving all your heavy microservices workloads into OpenShift, and then make them run as serverless, or even to Kubernetes platform, make them run as serverless by just using Knative behind the scenes. All right. And then let's try to wake it up. If I give a request back here again, so this is going to wake the service up. If you see this, the service is coming up right now, and then it's going to serve you the request. And then if you see, you should get the response back in a second. You got the response again, and then that's how it comes up and serve the request, right? So which means that if you go back to our serverless computing definition, we say that this particular thing is going to give you or kind of going to serve you only on demand, right? Executed, scaled, and built only for on demand. All right. So that's what we mean by this particular stuff. But let's make it a little bit more interesting, right? So what you have done right now is that you basically went ahead and done all these things. And these are some of the capabilities. So what we did right now is that, so we went and gave this request manually, right? Or any other application would potentially give a call to this particular service. So how good it will be if I want to do it based on events, right? For example, like let's take a very simple event in this case. Let's say I have a cron job, and the cron job keeps running every 2 minutes. I want the service to come up and serve the cron job and go back. Okay, I'll just take this very simple example. All right, so that will be a classic use case when I want to use the service only on demand. Okay, that's what I'm going to do right now. What I'm going to basically do is that I'm just going to create an event source, which is called as Knative eventing. We call them as event source in thing. When I go here, and just let me go and create this one in a second and then explain about this. So what I'm trying to create right now is I'm just trying to create a Knative eventing resource, and I'm also open the watch below. I'm just going to say this. Okay, this one particular thing is creating a resource right now. If you see this right now, and I don't have the resource right now up and running. If you see this eventing hello application has gone out, I say that every 2 minutes, I'm just sending some message to this particular eventing service, hello service, which is a sync here. End of the day, it goes to this particular Knative eventing service, which gets invoked every 2 minutes, right? Basically, I'm just probably in this case, I have to wait for 2 minutes because I want to show you it goes down and come up. You can reduce up to 6 seconds. That is the lowest thing which you can go up to for a service to respond. So in this case, what happens? This ping resource is basically going to run a cron job. Is going to run a job every 2 minutes, and every 2 minutes there is going to be a message. Is going to be posted to this particular Knative service, and once the Knative service receives a message, it's obviously going to come up, serve your request, and go down. Okay, so that's what is going to happen right now. This will be one of the classic cases. If you see here, the eventing allow application has come up here, and then once it comes up, let's watch this log for a second. So let me go here and then say cancel this. I say it's done. um I say eventing hello, and then if you see this, you saw this message coming up here for this particular service. So this is because my application has received the service right now. But ideally, if you see this, what happens is, like, let's go and watch the pods also in this case. Watch OC kubectl get pods. When I watch the pods right here, so what happens? Let's wait for some more time. We'll see this. Since it's going to be every 2 minutes, the service will not wait till 2 minutes. It will go down in few seconds, and then it will start again when we get the response back. Okay. In this way, what happens? I'm kind of responding. My service is kind of responding to a service, an event, an external event in this case, for example, a cron job, and then it's kind of responding to a particular application on that need. Okay. So this in this way, what we can also do is, like, we can make application responding to your external events. Okay, you'll also see about that. It's in the thing, the eventing thing is getting terminated right now, and there we go, it goes out of source as well. All right, so we'll make it a little bit more interesting and more realistic. So getting the next component here, how do you do with Kafka? So let me delete this one before we go further, so that, like, the event, we'll use the same eventing hello application again for the next one, but we'll not use the same source. We'll use a different source. So don't worry if you miss these commands or these other things. Everything is there on the Knative tutorial. The link is given to you on the chat, on the slides. So if you go to the tutorial, I put on everything. If you download the ebook, I put on all these things in the ebook as well, explain them in more detail and probably much slower way than what I'm speaking. So you can also go back and see them, and then you can also find the slides from dn.dev 4k-kubernetes as well. You can just download the slides from there. All right. So let's do this thing. So for example, so I already have a Kafka deployed, right? So let me go to my slides. So the next one is about Kafka. So one of the complexities with Kafka is that how do you deploy Kafka, right? So there are a few other things for you. We'll talk about Kafka. So with Kafka, one of the problems is, so let me not go this. Let me rush through this. There's no big thing. So one of the complexities, what we get with Kafka is when you take Kafka and deploy that on an Kubernetes cluster, right? So because Kafka deployment includes Kafka nodes, zookeeper nodes, and other stuff which is required for you, and then you have to create topics, you have to create other stuff, partitions, a lot of other things, right? Let's not talk more detail about that right now. But what you have done with that, with this particular project called a StreamZ, so we created an operator, again, a Kubernetes-based operator, which you can use to deploy Kafka inside Kubernetes cluster very easily, right? Without big hassle, I can go and create Kafka inside cluster inside my Kubernetes. I'm going to show you that as well in a second. So if you see this here, so if you go to this one, I'm going to go to the namespace called as Kafka. If you go to the namespace Kafka, you'll see this. I have a bunch of applications deployed. I have a cluster operator. I have 3 nodes of Zookeeper, my cluster, and 3 nodes of my Kafka thing deployed here, right? 3 Kafka clusters. And then I also have 3 Zookeeper clusters running them right now. I'll also show you, if time permits, I'll also show you how we can scale up and scale down as well. So you can just, with the click of button, as I showed you on the operator hub earlier, go to operator hub. You can just click on select Kafka, search for Kafka. You'll find this operator there. Click on that and deploy Kafka into your environment, right? That's so easy like that, right? And then scale up, scale down at your vision will. All right. So let's do a little thing. So let me go back here to my tutorial project here again. And what I'm going to do right now, earlier you saw that we are responding to a cron job, right? Which is not much interesting. Right now, what you'll do is, like, we'll respond to a Kafka topic event, right? So let's go and create this Kafka topic. I'm just going to go over there and then say create this topic here. See this, I'm just creating a CRD, which is custom resource definition in Kubernetes world. I'm creating a Kafka topic CRD. This is in turn is going to create a Kafka topic for you, right? I'm just going to create kubectl F, and then I say the Kafka topic is created. Let's see if Kafka topic is there. So if let's go and list this out. I'm just going to list this things up. Okay, there you go, right? So I have this Kafka topic created inside Kafka. I'm just kind of using a Kafka pod to list Kafka topics. It's a short, it's a script which I'm using to list all the topics. And there you see, right? So yeah, I just have this topic created, right? And now what we do is like, so we'll just go and create a similar thing like a ping resource. I also have a Kafka resource, all right? So what this basically is going to do is like, I just explain this for the second. I'll just create that and explain this. So what I'm trying to say that I have a Kafka source which gets created, and then the Kafka source is going to connect to my Kafka broker, which is running inside my cluster. And once the Kafka is going to listen to this particular topic, which is there, my topic, which we just created. So any message that is going to come into my topic is basically going to get to this particular eventing allow application. All right. That's what similar like what we did on the ping resource. We just send some arbitrary messages every 2 minutes. Now what we did is like we are going to do the same thing, but instead of sending to a ping message, we are going to ping to a Kafka topic. The Kafka topic is going to basically get this message for you. It's exactly going to be the same eventing allow application which you have. So let's start this one. So let's go and say Stern use a container. Right now we'll not be having any container right now. That's the reason why the logs are empty. So let's do this. So let's go and start the producer. Okay, let me go and then do producer, Kafka producer. Let me start again. All right. I did not kill this, right? So let me go and delete this producer again. I'm sorry about that. As I said earlier, I'm on a different machine, so kind of struggling with my keyboard and other stuff. So let me go to the administrator view. Just going to knock off this pod, I think, which I already have it started here. So workloads, pods, and then just going to delete this producer pod. Okay. Okay, let's go back and create this pod again. I'm just going to use a Kafka producer pod. Let me go and see if I'm able to get inside this. There we go. So we got inside, and then I'm saying hello, Bengaluru. Okay. And now you should see in a few seconds. Let's go back to our developer view onto our pods, which you have here on the Knative tutorial. You should see the eventing pod coming up in a second and serving your request, right? It was dormant all this time right now. And now you see it came back here and start to serve your request, right? So it started here, and you see this post message coming up right here for you as well. All right. And then let's do, I think we'll also let's for a sake of thing, let's send one more message. Hello, Chennai. I'm from Chennai, so I just give hello Chennai as well. And you see this message getting posted right now. In this way, what's right now happening is that your service, your serverless service in this case, is kind of responding to your Kafka events, right? The Kafka could be connected to the external world, or some other external application could be posting. There's a lot of permutation and combination there as well, right? And also, like the nice thing about that is right now, the moment I stop this, so you'll also see this spot is going to scale down in a second for you. And let me adjust the screen because I want to show you a little bit different thing in a second. I will put this one right there, and then let me click this one to see if I'm able to get your screen up there, right? So let me go back, details. Okay, there we go. I think this is what I want. And what now I'm also going to do is like the one last final demo before I close the session, because I'm not sure I have time for showing you a Camel K also today. So I think while this scales down, I also just runs you through this, the last part of the thing which you want to show that right now it's scaled down to 0. Let's wait for that to happen. So what I also want to cover quickly is that around another one which is called as Camel K. Let me quickly go through that. This is an enterprise integration where we bought Camel into Kubernetes. You can run Camel as a Kubernetes pod. I think I'm running out of time, so I cannot show this little one for you. So I'm just going to quickly show you one little demo of this. So what I'm going to basically do is like I'm just going to start a Camel thing right here. So which is basically a Camel endpoint. I'll show you that from my, so while I start this, and then I'll show you this one right there. As well. So let me go and install this up. Okay. But before that, let me show you the scaling piece of it, right? I'm not showing you. So we saw auto scaling, scale down. but the other way is that we can also scale up as well, right? So let before I go to camel k, which I need a bit extra time to do this, I'll also do the camel scaling stuff. Maybe the camel k part is completely there in the tutorial, you can just try it out by yourself as well. So but I want to show you the scaling side of things. So let me get into this. So let me go and say this particular pod. There's a pod called as a spammer. It's just a simple pod which allows you to do the scaling. I'm just going to do a scale. I'm just going to get into the pod. And as you watched earlier on my topology, I'm right now I don't have any pods running for this, right? Let's say what happens if there is a flow of messages. So that's what this cloud data streaming is all about. Right? When I get huge chunk of messages into my cluster, then what happens, right? So let's kind of simulate that case, localhost 8080, and then I say I get around 5 messages at a spot, right? I'm just playing with this example. You can go up to any number of messages. Right now, when I say this, basically what happens, you see this kind of getting scaled up right now, and then start to scale, right? You're scaling to 5 because there was no pods ready. It is kind of scaling up right now to kind of scale up and serve your request. Okay. I think this how like it can also respond to the scaling as well, which means that I can do auto scaling when the sudden spike of request comes in, and scale down when there is no request as well. Okay, Knative can serve in both the ways as well. And unfortunately, I don't have time to talk more about on Camel K. But I strongly recommend that you can go to the tutorial. I have a very detailed explanation about Camel K and also on the part of the book as well. All right. So with that, I think probably I will just want to leave with one single quote before I close. I think I have the resources here. You can just go to the resources link. Um, and then this one thing which I want to tell you about this is that already if you are doing cloud data streaming, this is the time that you need to start changing the way you do cloud data streaming with all these 3 4 components right there. That's only thing is that you need to start change, because change is the only thing that is not does not change anytime. Okay, I also bond into this context because with this current situation where we are in, so we have to build up our confidence saying that this situation where we are in is going to change, and everybody is going to start meeting up everybody soon. Until then, you stay safe and healthier. And I'll open up, give it back to Rahul Rohit for any question that I can take, or I can say goodbye.
Thanks a lot, Kamesh.